Okay, so picture this. You're an astronomer, scanning the skies for potentially dangerous asteroids. You know, the kind that could turn Earth into a cosmic billiards ball.
Right?
You spot something, run the numbers, and bam, it's on a trajectory to come unnervingly close to Earth.
Oh,
Panic.
yeah.
Maybe just a little,
Uh-huh.
but then you realize it's not a space rock. It's a car.
What?
And not just any car. It's Elon Musk's Tesla Roadster,
No way.
out for a spin around the solar system.
You're kidding.
I am not kidding. This actually happened.
Seriously, how do you miss that? I
Or-
mean, did nobody think, hey, that asteroid looks suspiciously like a cherry red convertible?
It's a fair question, but to understand how this happened, we need to dive a bit deeper into how astronomers actually track objects in space.
Okay. Yeah.
The Minor Planet Center,
MPC.
or MPC, yeah,
Hmm.
is the organization responsible for monitoring these celestial wanderers,
Right.
particularly those classified as near-Earth objects,
Neos.
or NEOs,
Yeah.
the ones that could potentially pay us an unwelcome visit. So, how did Elon's Roadster end up on their radar, so to speak?
Well, the Roadster, it isn't just parked in space. It's on a rather eccentric orbit that crosses the paths of both Mars and Earth.
Mhm.
So, depending on when and where it's observed, it can indeed resemble an asteroid, at least initially.
Okay, so it's cruising through space, making a cameo appearance in the asteroid belt. But shouldn't there be some sort of flag on it? Like, hey, this is just Elon's car, nothing to see here.
Ideally, yes, but the reality is there isn't a comprehensive centralized database for all artificial objects in space. The MPC relies primarily on telescope data and complex calculations to track objects, and sometimes things slip through the cracks, especially when you consider the sheer volume of objects we've launched into space.
So it's like trying to find a needle in a haystack.
Yeah.
But the haystack is constantly moving
Yeah.
and expanding.
Precisely. And this isn't even the first time this has happened. Other spacecraft, like the Rosetta probe and the WMAP satellite, have also been mistaken for asteroids in the past.
Wait, so seasoned astronomers have misidentified spacecraft as asteroids?
Mm-hmm.
Multiple times. You've got to be kidding me.
It's a humorous anecdote, no doubt, but it also points to a more serious issue, the growing challenge of tracking everything we're putting into space.
Right.
As we continue to launch more satellites,
Hmm.
probes, and even space tourists. This problem is only going to intensify.
Okay, so let's talk consequences. What happens if we can't keep tabs on all this stuff flying around up there? Are we talking potential space fender benders?
Sure.
Or something more catastrophic?
Yeah. The potential consequences
Mm.
are significant.
Okay.
First, there's the issue of wasted resources.
Mm-hmm.
Imagine astronomers dedicating valuable time and effort to study what they believe is a new asteroid, only to discover it's a discarded satellite or a piece of space debris.
Right.
It's not exactly an efficient use of scientific resources.
I can imagine the facepalms in the observatory.
Oh.
When they figure that out, oh, great, we just spent a month
Oh!
analyzing a discarded booster rocket.
But beyond the wasted effort, there's a much more serious concern, collision avoidance.
Yeah.
As space becomes more crowded, the risk of collisions between satellites, spacecraft, and even debris increases significantly.
Right, space is vast, but it's not exactly infinite. Eventually, all that stuff up there,
It starts bumping into each other.
and those collisions can't be good.
Exactly. Even a small piece of debris traveling at thousands of miles per hour can cause significant damage to a satellite or a spacecraft. And a major collision could create a cascade of debris, further increasing the risk of future collisions. This could ultimately lead to a scenario known as the Kessler Syndrome.
The Kessler Syndrome.
Yeah.
Sounds ominous. What exactly is that?
It's a theoretical scenario where the density of objects in low Earth orbit becomes so high that collisions create a chain reaction, generating a massive cloud of debris that could effectively make space travel impossible.
So basically, it's a domino effect of cosmic proportions.
Yeah.
And it all starts with a few pieces of space junk bumping into each other.
Exactly. It's a sobering thought, and it underscores the importance of developing effective solutions for tracking and managing space debris.
Okay, so we've established that space is getting crowded and that tracking all this stuff is crucial to avoid a cosmic demolition derby. What are some of the solutions being explored to tackle this challenge?
Well, one obvious solution is creating a comprehensive centralized database of all artificial objects in space. Everything from active satellites to defunct rocket stages and even tiny fragments of debris.
That sounds like a massive undertaking. Who would be responsible for compiling and maintaining such a database?
You're absolutely right. It would be a colossal effort requiring international cooperation and data sharing on an unprecedented scale. It would involve governments, space agencies, private companies, and research institutions all working together.
So basically, we need the United Nations of space junk to step up and take charge.
In essence, yes. We need a global entity dedicated to tracking and managing space debris, establishing international standards for data sharing and coordinating efforts to mitigate the risks.
Okay, but let's say we manage to create this ultimate space junk inventory. How do we actually keep track of all these objects zipping around at ludicrous speeds?
That's where technology comes in. We need to invest in more advanced tracking systems, including ground-based and space-based sensors, telescopes, and radar systems. But we also need to leverage the power of artificial intelligence and machine learning.
AI and machine learning for space junk. That sounds futuristic.
It's not as far-fetched as it sounds. These technologies have the potential to revolutionize how we monitor space debris. They can analyze vast amounts of data from various sources, identify patterns, and predict potential collisions with a level of accuracy that would be impossible for humans alone.
So we're essentially training robots to be cosmic traffic cops, making sure everything stays in its lane.
In a sense, yes, AI can also help us develop more efficient methods for removing debris from orbit, whether it's capturing and deorbiting large objects or using lasers to vaporize smaller fragments.
Laser beams vaporizing space junk. I'm sold. But let's shift gears for a moment and talk about the Roadster again. What's its ultimate fate? Is it going to keep orbiting the sun indefinitely?
Well, that's where things get really intriguing. Back in 2018, researchers conducted simulations to predict the Roadster's long-term trajectory. They took into account its current orbit, the gravitational influence of planets, and various other factors. Their findings suggest there's a chance, albeit a small one, that the Roadster could eventually collide with Earth, Venus, or even the Sun.
Hold on. Are you saying there's a possibility, however remote, that Elon Musk's car could come crashing back to Earth like a flaming cosmic boomerang?
Technically, yes, but we're talking about millions of years from now. It's not exactly an immediate threat.
Okay, phew. That's one less thing to worry about. But I have to ask, isn't it a bit ironic that the guy who's championing space exploration and sending people to Mars is also responsible for sending a car on a potential collision course with Earth?
It's certainly an interesting point. It highlights the complex and sometimes contradictory nature of space exploration. On the one hand, we're driven by the desire to explore, discover, and push the boundaries of human achievement. On the other hand, we have a responsibility to minimize the risks and ensure the long-term sustainability of our activities in space.
It's a balancing act, for sure. We want to reach for the stars, but we also need to be mindful of the footprints we leave behind. Speaking of footprints, let's talk about the Roadster's legacy. It's not just a piece of space junk, is it?
Absolutely not. The Roadster has become a cultural icon, a symbol of human ingenuity and ambition. It's captured the imagination of people worldwide and sparked conversations about our future in space.
It's also a testament to Elon Musk's flair for the dramatic liner. I mean, who else would launch a car into space just for kicks? But beyond the publicity stunt, it's raised important questions about the future of space exploration and our responsibility for managing the debris we leave behind.
Precisely. The Roadster's journey, as whimsical as it may seem, serves as a potent reminder of the complex challenges we face as we venture further into the cosmos.
So it's a cosmic joyride with a serious message. But before we get too philosophical, tell me more about the Roadster itself. Is there anything else on board besides Starman, the dummy astronaut rocking out to David Bowie?
Well, there's a data storage device on board containing Isaac Asimov's Foundation trilogy.
So it's a time capsule for future civilizations, assuming they can figure out how to play a 21st century data storage device.
And who knows, maybe someday, millions of years from now, some alien civilization will stumble upon this Roadster with its faded paint job and dented bumper and wonder what strange creatures created such a thing.
I can just imagine the headlines. Mysterious ancient artifact found in asteroid belt contains evidence of primitive life forms obsessed with electric cars.
Indeed, it's a fascinating thought. But even if the Roadster never encounters extraterrestrial life, it will continue to orbit the sun, a silent testament to human ingenuity, ambition, and perhaps a touch of whimsy.
A cosmic monument to our desire to explore the unknown, even if it means occasionally mistaking a car for an asteroid.
That's a rather poetic way to put it, but it captures the essence of this story. The Roadster's journey is a reminder that space exploration is full of surprises, challenges, and opportunities. It's a journey that requires careful planning, technological innovation, And perhaps most importantly, a sense of wonder and a willingness to embrace the unexpected.
So we've covered a lot of ground today, from mistaken identities in space to the potential perils of space junk and the need for cosmic traffic control. But before we wrap up this deep dive into the saga of Elon's Roadster, I want to bring it back to what this all means for you, our listeners.
That's a great point. It's easy to get caught up in the technical details, the scientific jargon. But the reality is that space exploration impacts us all. It shapes our understanding of the universe, inspires innovation, and raises profound questions about our place in the cosmos.
Absolutely. And this whole incident with the Roadster, as humorous as it is, serves as a reminder that space is still a very unpredictable place. We may have sent probes to distant planets and rovers to Mars, but we're still learning and adapting as we go.
Precisely. And as we venture further into space, we're bound to encounter more surprises, more challenges, and more opportunities to learn and grow.
So what's the big takeaway for our listeners today? What should they be pondering as they go about their day, navigating the terrestrial world, so to speak?
Well, I think the key message here is that space exploration is not just about rockets and astronauts. It's about expanding our knowledge, pushing the boundaries of human ingenuity, and ultimately, understanding our place in the grand scheme of things.
Beautifully said. And for those who might be thinking, well, this is all very fascinating, but what does it have to do with me? I would say, remember this. The technologies we develop for space exploration often have applications here on Earth. From satellite communication to GPS navigation, space exploration has a tangible impact on our daily lives.
And as we grapple with the challenges of space debris, we're developing innovative solutions that could have implications for sustainability and resource management here on Earth.
So it's a two-way street. Space exploration benefits from the ingenuity and innovation happening here on Earth. And in turn, it inspires us to think bigger, bolder, and more sustainably.
It's a symbiotic relationship, a cosmic dance between humanity and the universe, a dance that's full of wonder, challenges, and endless possibilities.
I love that, a cosmic dance. And on that note, it's time to wrap up this deep dive. But before we go, a final thought for our listeners to ponder. As we continue to explore space, what are our responsibilities to this vast and largely unexplored frontier? How can we ensure that our exploration is both ambitious and sustainable? Leave your thoughts in the comments below. We'd love to hear from you.
And while you're at it, if you enjoyed this deep dive into the world of mistaken asteroids and cosmic joyrides, be sure to subscribe to the channel for more fascinating explorations of the universe and beyond.
Until next time, keep looking up, stay curious, and remember, even in the vastness of space, there's always something new to discover, even if it turns out to be a car,